Alright, this is lesson number 69. We're going to be talking about different types of interest and some ways that we can model different systems that involve interest. So, first thing we're going to start off with is an example about simple interest. So, suppose you receive $1,000 for graduation and you want to save it. So, you consider putting the money into a bond. This bond will give you a 12% return annually in the form of monthly payments. Consider how much you will have at the end of a year, and how can we model this situation. So first, this 12% annually is another word for yearly. So after 12 months, you get 12%. So that means if it's monthly payments, each month you would get 1% of that. Okay, so basically the math that we do there is just take the 12% or 0.12 as a decimal and divide that by 12 because that's the number of months in a year. Okay, so we get 0.01 when we do that, which is 1%. Okay. So now I'm thinking, okay, how much am I going to get each month? So I put in $1,000. And they're telling me they're going to give me 1% of that. So if I multiply that by 0.01, I can just move the decimal over 2 places and I'll get $10. Okay, so that tells me at the end of the first month, I will have $1,010. Okay, then another month goes by, they're going to give me back another 1% of that original amount. So I'm going to get another $10. And I'll end up with $1,020. Oh, sorry about that. Okay, so $1,020, and then after another month, I get another $10. I'll have $10.30, and so on. So it'd be nice to probably organize this information into a table, right? 12 months is kind of a long time. So in class, we started using an app on the iPads called Numbers, which is the Apple's spreadsheet program. So it looks something like this. So we made our table with the time as the first column. So we did the time in months, and then we considered how much money we would have. Ignore this second column for me right now. So this is just a screenshot from the Numbers app. To input information on this, if you're wanting to follow along at home, you would double click on a cell. So you just double tap it and then you can enter in information. These 4 options right here give you different types of values. So the 42 is numbers, that gives you this screen that's showing. The clock is like date and time type of things. The T is for text, and then the equal sign is for equations, and we'll talk about that a little later. So for the numbers, I would come here, I would say, okay, I'm going to put, for 0 months I have 1,000, right? I start off with that much. Then I would type in 1,010 as my next month of values and go on from there. I could also use the equation feature. So if I click that equal sign that was there, I would end up with a box like this. And what I did to kind of make this easier is I told the computer, okay, instead of just putting in the numbers, I told it I want you to take the last number, the last amount that I had from the month, and add $10 to it. Okay, so I did that by hitting equals, and then to get this up here, I just tapped the box, and then I put plus 10. Okay. Okay, so that would give me the formula, and I can actually copy and paste this formula. So I would tap on the cell and hit copy. So just tap here and you hit the copy option, and then highlight the rest of the cells and click paste, and it will copy that formula. So it'll get this, but instead of saying, oh, look at this cell, it'll always tell it, okay, look at the cell above, look at the cell above, and add 10. So it'll continue working how we want it to. Okay, and here's what that screen looks like. So in order to select all the rest of these rows, you just click on one of the cells, and then the blue box pops up here, and you just drag it down so that it takes up the whole area that you want. and you would click this button here that says Paste Formulas, and you would end up with all the values in there correctly. Okay, so this is what you get, again ignoring this column for now. But this is what you would get for that first example. So putting it in the bond at the end of the year, you would have $1,120. We could try to model this with an equation if we think, okay, each month it's going up $10. So each month up $10. Each month over month up $10. So I start with $1,000, and after 1 month I go up 10 each time. Okay, so this should be reminding you of the slope of a line, right? So this is just a linear function. My equation then would be y equals, then my slope is 10, so 10x, and then plus my y-intercept. This was at 0, right, at 0 months, so my y-intercept would be 1,000. And that's it. That's how I could model this example using a linear equation. Okay, and then maybe as another option, you want to look into a savings account that says that they use compound interest. So this account in particular says they will give you an annual percentage rate, or an APR, you might see, of 12%, and it's compounded monthly. Okay, so 12% annually again, so that means over the year you're getting 12%, which means each month is 1%. Okay, again, this from similar to the last problem. Okay, but what the compounded means is that they are taking your new balance. So before, they just said, oh, okay, you have $1,000 in your account, so we'll take 1% of that and give you $10 each time, plus 10, plus 10. Okay, but now they're saying, oh, well, you had $1,000, but now once we added the 10%, I'll go ahead and put it over here. So you had $1,000. Now once we take 1%, you have $1,010. So now we're going to look at the $1,010 and take 1% of that to give you your next monthly, the next amount of monthly interest. Okay, so that's going to be $10.10 now. If I add that to my last month's total, I now have $1,020.10. Now I'm going to take that new total, so $1,020.10. Oh, sorry. I multiply that by 1%, that gives me $10.20, and I add that to my last month's total in order to get where I'm at for the end of the third month. Okay, so we could also put these values into a table and look at how this is growing, and try to come up with some sort of an equation that will help us to create the table more quickly, so we don't have to continually do this. So let's go ahead and look at that. These are the first two, so I inputted the values in the table. That's why I made this other column for the compound interest. I want to leave these here, the simple interest ones here, so that I can compare them. So I'll just put it in the next column over. This screenshot here is to show you how you can format different columns. So you just highlight, so you click and drag to highlight whatever sections you want. And the paintbrush up here gives you a menu. If you click on format, it gives you these options, so it's telling you how you want to format those numbers. So for these, I would choose currency, so that it has a $sign and 2 decimals. Okay, so now we're on our table for the compound interest. So I could just go through and put in these numbers and keep calculating them one at a time, but we could also take advantage of the resource that we have with these spreadsheets and use them a little more to their full potential. So if we use the equal sign, right, when we have those 4 options, if you hit equal sign, you'll end up here. And then this is what I did for the equation. So here I want to take just like how we did on the last slide, you want to take the last month, multiply it by 1%, and then whatever number you get, you want to add that to the last month. So to, in this case, 1010. Okay, so I'm telling the computer to do that. I'm saying, hey, take the last month, multiply it by 1%. Whatever you get there, I want you to add it to last month's money, right? So this might give you like $10 and something cents, and then you're going to add it to what you had last month to get your total. Okay, so again, this is just a screenshot. I can't really flip back and forth with recording on here, but hopefully this will give you an idea of how we did the activity in class. Okay. A couple last points for our activity. So we, again, I did the copy and paste thing. So I made the formula for this box. I clicked and copied it. And then I clicked right here. I highlighted this whole box. I clicked and I hit paste for the formulas. Okay. So once I have all these tables, I can compare, or all the values in the table, I should say. I can compare what's going on after a year, see which option I like better. See, unfortunately, there's not a huge difference, but I do get a little bit more if I go with the savings account. The compounded interest goes up a little more each month. Okay. Now what I was, this screenshot is to show you how you can add a table. So I highlighted, you can see in blue, I highlighted everything that I need, including the headers. Okay, and then I went to add, and I clicked on this one for the chart. If you're at home and you have Google Sheets, Google Sheets works in a very similar way. It's a little less, I guess, user-friendly maybe, but it's very similar. The spreadsheet is, it just goes through the whole, there's more like rows and columns on those. But if you are understanding this, you could definitely apply the skills that I'm talking about here to Google Sheets or Microsoft Excel. Okay, they're all in the spreadsheet family. Anyways, back to this though, so you could add a chart and you will get something that looks like this. Okay, so here I added in my chart. You can see it goes from 0 to 12 months on the x-axis. And they started down here at 900 and went up to 1200. So I might want to adjust that so that it looks a little prettier. If I wanted to do that, I could select my chart and then by clicking it and go to the paintbrush and hit format, and there's some options in there that I can mess with the y-axis values. But for now, I just wanted to show you what it automatically gave me. So I can see if I zoom in, remember this blue was our linear. If you look here, blue was the simple interest. It says up here it's labeled simple. That was our line y equals 10x plus 1,000. Okay, the green one though, you might notice it starts off the same path and then it kind of starts to curve up. So it'd be interesting to see what would happen afterwards, right? How much it might continue to go up. So let's investigate that now then a little further. So for the next thing that I did was to show the class on my table. I used the formulas and everything, and I had it go up to 60 months. So I looked at what about after 5 years. So this is 1 year, you know, leaving your money in a bond or in the bank, some of the differences. But let's see maybe after 5 years. So that will give me this. Okay, if you look down here at 60 months, you can see the difference between the two is a little more drastic. And in the graph, I adjusted the graph here. I made the scale start at a minimum value of 1,000, so that gives me a little bit of a better picture. Before we just were looking up to 12 months right here, so that's why I see the green's only pulling off of it a little bit. But if we look over here after 5 years, there's a big difference. So that says something about keeping your money in those accounts, right? It's definitely the longer it's in there, it's going to just keep moving up. Alright, so now we wanted to see how we could model the equation in green. So this is the compound interest, okay, the green dots. So it is curving up slightly, and it might not really look like it from this, but this is actually an exponential function, okay? So what we've been studying in this last chapter. We'll look at the actual formula for this here, and I encourage you to make a table of some of these values on Desmos and compare it to the following equation with the values plugged in. So here is the compound interest formula. Okay, these are what each of the variables mean. So A is the amount that we have, so I say if I leave it in for 5 years, I end up with, let's see, this one, leave it in for 5 years, I ended up with $1,816.70. Okay, so that would go in place of A. Okay, and I could check, I probably should have done this in class, I could check to see if this works, so I could do $1,816.70. And I could check, is that equal to, my principal was $1,000. Principal is the amount that you initially invest. 1 plus, and then R over N. This is what we were doing just kind of automatically when we talked about 12% over 1 year. So we did the rate, which is the percent per year, as a decimal, so 0.12. We divided it by the number of times the interest was compounded each year. So that was monthly, so 12 times in the year. And then that's going to be raised to the 12 times t power. So we looked at after 5 years. So this would be something that you could put into your calculator to see if you get that same answer. Doing some simplification, I get this equation. So you could check, do 1.01 raised to the 60th power, multiply that by 1,000, and you should end up with this. That's all for today's lesson. It was mostly that activity today to get some hands-on experience working with spreadsheets. So that was it for today. And then this equation is what you're going to use for your homework tonight, and these values. Okay, so plug in the values that you know and solve for the unknown value. Okay, good luck, and I will see you tomorrow. Thank you.